The molecules that we've been looking at so far have had atoms that the carbons are all connected in a straight line. Now, when I say straight line, they do kind of zigzag if you look at the shape of the molecule themselves, but we can go from one carbon to the next. Everything is connected in one continuous chain. So this, because it has 1, 2, 3, 4, 5 carbon atoms, would be called pentane. All of those carbon-carbon bonds are single bonds. But what if I have a branch coming off of one of these carbons? So if I take off that hydrogen and replace it with a carbon chain here, now I have 1, 2, 3, 4, 5, 6, 7 carbon atoms. But I wouldn't call this heptane because that would imply that all 7 carbon atoms are in a straight line. But we can see here, instead of just going one after another, this carbon is bonded to another group of carbons. So we have a branch coming off of here. So if you have all of them in one continuous chain, it's a straight chain alkane, and you just count up the number of carbons and name it like that. But if it's got a carbon that has a bond to 3 other carbons, then we have a branch, and we have to name that a little bit differently. Now, the first thing that we have to do is find the longest chain, because molecules aren't just sitting stationary. And I can see that I have a chain of 5 here, but if I rotate this a little bit, maybe a little bit more clearly, you can see I have 1, 2, 3, 4, 5, 6 in a chain. Well, 6 is greater than 5. So when I go to name a molecule, there can only be one correct name for it. So the first thing that we have to do is to find that longest chain, keeping in mind that we can bend and curve as long as we're following along carbon-carbon bonds. Once I get to here, I could either go down or I could go over here, and I want to find the longest chain. Also, when we're going to number the carbons, because we're going to have to tell where that branch is coming off, just like we would for where the double or triple bond is in an alkene or an alkyne, we need to remember that, again, this thing's flipping around. There is no left side and right side. So once I've found the longest chain, I can count from both directions my carbon atoms, and I'm always going to use the smallest number. So for example, 1, 2, 3. Here I've got that carbon branch coming off of 3. 1, 2, 3, 4. There it's coming off of carbon number 4. 3 is smaller than 4. So I'm going to number from the side that's closest to where that branch occurs. So essentially, even though our diagrams might look like we've got nice straight lines and right angles, we really don't. It is just a jumble of atoms at all sorts of weird angles that's constantly moving around. So there is no, we have to go in a straight line horizontally across the page. We can twist and bend and curve and follow chains that way, because they don't look as straight as we actually draw them quite often. The other thing that I want to talk quickly about is how we write the hydrocarbons. There are lots of different methods to write organic molecules. The ones that I've done so far, I've drawn out the carbons and I've drawn out all of the bonds to hydrogen as well. But when we get really big molecules, this can end up becoming a little bit more cluttered to read with all of the hydrogens there. So another way that we can write this is, instead of writing the carbon with the bonds and the 3 hydrogens, we can take this piece and write it as CH3. This is forming what's called a condensed structural formula. It's pointing out where all the carbons are. It's still telling us how many hydrogens, but it's not drawing all of them in with their bonds. So that would be CH3, single bonded to, this is a carbon with 2 hydrogens, bonded to a carbon with 3 hydrogens. really all you need to focus on is the carbons. The hydrogens are just there because they are in the molecule, but we're only focusing in on the carbon atoms when it comes to naming them. There are ways of condensing this even further, but this is as condensed as we are going to get in this course. So if you see the CH3 or a CH2 or something like that, that just means those 3 hydrogens are actually bonded off of that carbon like this. It just kind of unclutters the image for us a little bit.
The first thing you need to do is find the longest carbon chain, which is called the parent chain. Then you're going to number the parent chain so that the branches, which are called substituents, get the smallest possible number, just like we did when looking for what number to give the double or triple bond in alkenes and alkynes. Next, you're going to name the substituents in alphabetical order as number dash prefix YL. For example, a 1-carbon branch would be a methyl group. If more than one identical substituent exist, then use the prefixes di, tri, or tetra, the same ones that we were using when naming covalent compounds. So if something has 2 methyl groups, it would be dimethyl. Here's our first example. And again, the first thing we need to do is find the longest chain. If I were to go straight across, I would have 1, 2, 3, 4, 5. But if I go across and down, 1, 2, 3, 4, 5, 6, I have a longer chain. So notice I need to be looking at carbons that are connected by bonds, and I'm looking for the longest one. Then we're going to number them starting from both ends. If I number it from the left, I get 1, 2, 3, 4, 5, 6. If I number from the right, I get 1, 2, 3, 4, 5, 6. So they're both chains of 6, but am I looking at starting on the left or on the right? Well, to determine which one I want to do, I need to look at where my branches are, what my substituents are. Here I have 2 substituents. Both of those substituents have 1 carbon in the branch, so they're both methyl groups. Looking at the blue numbers, I have 1 coming off of carbon number 3 and 1 coming off of carbon number 4. If I look at the red numbers, I have 1 coming off of carbon number 3 and 1 coming off of carbon number 4. So for this one, it actually doesn't matter where I start numbering my chain. Both are going to give me the same answer. But again, if it gives you different answers, you're always going to go with the one that gives you the smallest numbers. So again, we need to give the numbers for the branches, which is carbon number 3 and carbon number 4. And then there are 2, so di, both of those are methyl groups. So 3, 4, dimethyl. Numbers are separated by commas. Numbers are separated from letters by dashes. And then we're going to name the parent chain, which is a chain of 6, which is hex, and all single bonds, so hexane. So the name of this molecule is 3,4-dimethyl hexane. All right, again here, first thing I need to do is find my longest chain. When you're doing this, make sure you're looking at all different ways of connecting. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So here there are 2 different ways that get me chains of 6, and either of those ways will work. They'll both give me the same answer. So again, if I number from the left and then number from the right, and then I need to identify my substituents. So I have an ethyl group here and an ethyl group here. Now on this one, if I look at the blue numbers, I have both of them coming off of carbon number 4. If I look at the red numbers, I have both of them coming off of carbon number 3. So in this case, it does matter which one I use, and I need to go with the red numbering. Again, there are 2 groups, so it's going to be di. Each one of those I need to have the number with. Even though the number is the same for both, I do need to have 2 numbers. So this is going to be 3, 3, coming off of carbon 3 and coming off of carbon 3. Di, because there are 2 different substituents. Each of those groups has 2 carbons in the chain. The prefix for 2 carbons is F, so 3,3-diethyl. And then again, there are 6 in the longest chain, so that would be hexane. All right, once again, I need to find the longest chain of carbon atoms. In this case, the longest chain has 9. So I can number from either side. Just need to figure out how to get it to show up. All right, so next I'm going to look at where my groups are. Notice some of these groups have 1 carbon in the chain, some of them have 2 carbons in the chain. So I do need to distinguish between those. So there's a 1 carbon, a methyl group, another methyl group, and another methyl group. And then I have 2 carbon chains. So I've got an ethyl group here, another here, and my last one is here. All right, so if I look at these numbers, starting with the blue, my first branch is on carbon number 3. Starting with the red, my first group is on carbon number 4. So I want to go with the blue numbering that has the 3 because 3 is less than 4. Now, remember, when we put these groups in, we need to name them in alphabetical order. So methyl only has 1 carbon, ethyl has 2, but E comes before M, so I put the ethyl groups first, which again I'm dealing with the blue numbers, so let me get rid of the red ones for now. So for the ethyl groups, 4, 5, and 5. So 4, 5, 5. There's 3 of these groups, so tri. There are 2 carbons in the chain, so ethyl. Then for the methyl groups, we have carbon 3, carbon 6, and carbon 6. So 3, 6, 6, tri because there are 3 of them, methyl because there's 1 carbon in each of those chains, and then a total of 9, so nonane. So this is 4, 5, 5 triethyl, 3, 6, 6 trimethyl nonane. Once again, we need to find the longest chain. So we can number it from the left or from the right. There we go. All right, and then I'm going to circle my substituent groups. I have a methyl group here. I have a methyl group here and a methyl group here. And then an ethyl group and another ethyl group and a propyl group and a propyl group. Now, if I start counting from the red, my first branch is off of carbon 4. If I start counting from the blue, my first branch is off of carbon 4. So we need to look at more than just where the first branch is now. So if we look at all of the numbers, I would have 4, 4, 5, 5, 6, 6, and 7 for the blue numbering. For the red numbering, I would have 4, 5, 5, 6, 6, 7, 7. So the blue one gets me smaller numbers than the red does. So once again, we're going to go with the blue numbering. And alphabetical order. So ethyl is going to come first, which is the 2 carbon chains. One off of carbon 5, one off of carbon 6. So 4,6-diethyl, carbon 4, carbon 6, 2 of the same groups, di, 2 carbons in the chain, ethyl. Then methyl, 4, 6, and 7. There are 3 of those groups, so tri, 1 carbon in the chain, methyl. And then the propyl groups coming off of number 5, both of them, 5, 5, dipropyl, longest chain is 10, which would be decane. So again, it's the ethyl, methyl, and propyl parts that get put in alphabetical order. Ignore the di, tri, tetra, etc. when you're putting them in alphabetical order.
Here we have a branched alkene. Branched alkenes or alkynes would be named just the same as a branched alkane and indicating where that double or triple bond is, just like we did earlier. Now, I did leave the hydrogens off here just to kind of keep us from getting confused about, to unclutter the picture for us. Longest chain is going to be 4, whether I go 4 across or across and down, it really doesn't matter. So just for fun, I'm going to go the across and down. Again, we're going to number from both sides. 1, 2, 3, 4. And 1, 2, 3, 4. Now the 2 things that I'm going to need to locate are the branch and the double bond. So again, we want to look at the numbers. If I use the red numbering, my double bond starts at carbon 2 and my branch is coming off of carbon number 3. If I use my green numbers, the branch is coming off of carbon number 2 and the double bond is starting at carbon number 2. So we're going to want to use the green numbers because those are going to give us smaller numbers than if we used the red ones. So again, I need to name the branches first. There's 1 carbon in this branch. The prefix for 1 carbon is meth, so this is a methyl group. And it's coming off of carbon number 2. So 2-methyl, dash. So again, numbers are separated from words by dashes. So dash coming off carbon number 2 is my double bond, which is going to make this be an alkene ending in ene. And there are 4 carbons in that longest chain. The prefix for 4 carbons is bute. So 2-butene. So coming off of carbon 2, there is a 1 carbon chain. Coming off of carbon 2, there is a double bond, and there's a total of 4 carbons in the longest chain.